In this video, we will talk about vector addition and vector subtraction. Now, to understand the addition of two vectors, let us consider two vectors A and B that lie in the same plane, or I shall say that both these vectors A and B are coplanar, as can be seen in this figure. Now, you must note that here the lengths of the line segment representing these vectors are proportional to the magnitude of the vectors. Now, to find the sum of these two vectors, you would have to place vector B so that its tail is at head of vector A as shown in this figure. After this, join the tail of vector A to the head of vector B. As can be seen from the figure, this line OQ represents vector C, which is equal to the sum of both vectors A and B. So here we have vector C is equals to A plus B. This procedure of vector addition where two vectors and their resultant form three sides of a triangle is known as triangle method of vector addition. Let us learn more about vector addition. Now, vector addition is commutative. That is, if we find the resultant of B plus A, then we obtain the same resultant vector, that is C. So here we have A plus B is equals to B plus A. Another property of vector addition is that it is associative. That is, the result of adding vectors A and B first and then adding vector C is same as the result of adding vector B and C first and then adding vector A. Now consider two equal and opposite vectors A and minus A as shown in this figure. Now if we add these two equal and opposite vectors, their sum would be equal to 0. That is A plus minus A is equals to A minus A, which is equals to 0. This is because the magnitude of these two vectors are same, but they have opposite directions, and the resultant vector has 0 magnitude and is known as null vector. Since null vector has 0 magnitude, we cannot specify its direction. Now I would like to state one more point about vector addition. That is, when it comes to add vectors representing physical quantities like displacement, here while drawing diagram for addition of displacement vectors, you are not required to draw vectors to their actual size. It is often convenient to use a scale in which the distance on diagram is proportional to the actual size. For example, in vectors, you can use 1 centimeter to represent 10 kilometers, just as you do on the map. You can use such scales with other vector quantities. For example, in case of force, you might use a scale in which 1 centimeter long vector represents a force of 5 Newton. Now we move on to subtraction of vectors. Subtraction of two vectors can be defined in terms of addition of vector. For this, consider a case when we multiply a vector say A by minus 1. So, minus 1 into A is equals to minus A. And this minus A is by definition a vector that have the same magnitude as vector A but have opposite direction. So here the difference of two vectors A minus B can be defined in terms of sum of two vectors A and minus B. That is, A minus B is equals to A plus minus B. And we can use triangle or polygon method of vector addition to get our answers. To understand subtraction of two vectors, let us consider two vectors A and B as shown in this figure. Now this figure also shows a vector minus B, where minus B is equals to minus 1 B. So, as we stated earlier, difference of two vectors A and B would be equal to the sum of two vectors A and minus B. Now, to obtain the difference, we would place vector minus B in such a way that its tail is at head of vector A. So, this figure shows both addition and subtraction of vectors A and B for the purpose of comparison. Here vector R2 is equals to A minus B, which is the difference between two vectors A and B, and vector R1 is equals to A plus B, which is the addition of two vectors A and B. Next thing I want to talk about in this video is parallelogram method of vector addition. Again, to understand this method of vector addition, let us consider two vectors A and B. Now to add vectors using this method, place the tail of vector B so that it meets the tail of vector A as shown in this figure. In the next step, take these two vectors to be the first two adjacent sides of a parallelogram. And now draw the remaining two sides. In this figure, dotted line shows remaining two sides of the parallelogram. Now to get the sum of vectors A and B, draw a vector that extends from the tail of vector A and B across the diagonal to the opposite corner of the parallelogram. Now in this figure, vector OR shows the sum of vectors A and B. So this OR is equals to R is equals to A plus B. Sometimes it is common error to draw some vectors as diagonal running between tips of two vectors. For example, vector QP in this figure. This is incorrect. It does not represent the sum of two vectors. In fact, it represents the difference, that is A minus B. So we can use both triangle method and parallelogram method to add vectors. Now for more notes and study material, you can visit our website physicscatalyst.com.